Session number 2 of coordination compounds is about nomenclature of coordination compounds. We are going to name the coordination compounds here. As we know, the coordination compounds contains central metal atom which is surrounded by ligands. Usually, we write the central metal atom which is surrounded by ligands within the braces, within the brackets. We call it as coordination sphere. And outside the square bracket, outside the parenthesis, we have counter ions. We have ions that may be positive or negative, that we call it as counter ions. Complex ion is nothing but the charged species which contains central metal atom as well as ligand. In short, I can say the term what we write inside the bracket, we call it as complex ion. So, complex ion is a charged species, whether it may be positively charged or it may be negatively charged. We have such complex where it is neutral. We don't have any charge over there. So, based on this concept, I classify these complexes into three types: positively charged complex ion, negatively charged complex ion, and neutral complexes. So, we'll name these compounds in first cation and anion and next neutral complex ions. So, first I am going to move with the nomenclature of cation complex. As I said, cation complex is nothing but the complex containing positive charge, positively charged complex. And in concept complex, we have central metal atom which is surrounded by ligands, and the ligands used to donate a pair of electrons to the central metal atom through coordinate bond. Now, for this cationic complex nomenclature, we have to follow the rule. The rule I have written in a very short manner, and the same has to be followed for the examples here. I consider some examples also. First, we need to consider ligand name, and I think if I mention any coordinate compound, you are going to find out which one is central metal atom and which one is ligand. And first, ligand name we need to write. After that, metal name we are supposed to write, and after that, oxidation state of central metal atom, and later we are going to write an ion name in case of cationic complex. So, ligand name. In the previous session, I have given different types of ligands: monodentate ligand, bidentate ligand, polydentate and ambidentate, and I have listed many examples, the symbols as well as the names, and you need to know that, and based on that you need to write the ligand name. Next, metal name. So, usually the transition elements are going to form complexes because of its properties. Therefore, metal name of the transition metal we are supposed to write. And after that, oxidation state. So, you need to find out the oxidation state of a central metal atom or ion in a complex, and we know how to find the oxidation state of central metal atom. And you need to follow the rule, and we need to write the oxidation state. Remember, oxidation state has to be written in a Roman number within the brackets or parenthesis or braces, you can say. So, oxidation state has to be written after the name of the metal in a bracket in a Roman number. And next we need to write the anion name. Anion, negatively charged species, that we are supposed to write the name as it is. So, this is how we are supposed to follow the rules to write the name of a cationic complex. But remember, if you consider this particular example, and now you can easily say the term inside the bracket is nothing but the coordination sphere, and we have ligands as well as central metal atom, and outside the bracket we call it as counter ions. And in these cases, in cationic complexes, counter ions are negative ions. Remember, counter ions are anions actually. First, while writing the name of coordination sphere, you need to write the name in a continuous fashion. There should not be no gap between the names what you write. The ligand name, metal name and oxidation state what you write, continuously we need to write without any gap. Whereas after the coordination pair we have a counter ion. So while writing the counter ion we need to leave a space or gap to write the anion name. This rule you are supposed to follow. And remember, in Iupac nomenclature of coordination compounds, all the alphabets are small alphabets only. You need to start with small alphabets and you need to write the name. So we'll see examples, then we'll understand how to write the nomenclature of cationic complex better. First we'll see whether this is cationic complex or anionic complex or neutral complex, and it is very important to find out that, as I said, cationic complex, on the complex you should get a positive charge. And how you identify the complex? In the complex we have a central metal atom and ligand. In simple I can say the bracket term what you write, that is actually the complex. So now you just observe here. So we have a Cl. Okay, so this chloride ion is of a negatively charged. Okay, Cl minus it is, and Cl minus totally 3 we have, so the charge of this will be 3 minus, isn't it? So if the charge of counter ion is 3 minus, then the charge of complex is 3 plus, because the coordination pair and the counter ion, they are going to balance the charge each other. The charge is going to be balanced. Since Cl3 we have and the charge is 3 minus, 1 Cl 1 minus we have, 3 Cl we have 3 minus. Since it is 3 minus, the charge of the whole complex is 3 plus. Since the complex has a positive charge, therefore this belongs to cationic complex. This is how you need to identify that. Later, concentrate on coordination pair. Concentrate on the terms within the square bracket. So here we have capital C small o stands for cobalt. Capital C small o cobalt, capital C capital O carbon monoxide, don't confuse with these two. So cobalt it is. So we have a NH3 and 6 times we have. I think now you can guess which one is the central metal atom and which one is the ligand. And we know that already. The ligands are Lewis bases that has the lone pair of electrons for donation, whereas the central metal atom, they are Lewis acids. In general I can say D block elements these are, and ligand are going to surround the central metal atom. If you have this concept, and now you can easily guess, cobalt is the central metal atom and NH3 will be the ligand. So first what we have to do, ligand name we have to write. So NH3, so do you remember the name of the ligand? So what is that? NH3, the name of the ligand is amine. So you just recall the types of ligands what I discussed. NH3, the ligand name is amine, NH3, and it is a monodentate ligand because it has one lone pair of electrons for donation. So amine belongs to monodentate ligand. Actually it is a neutral molecule. Since if you know, the monodentate ligands can be classified into 3 types: negatively charged, positively charged and neutral. And NH3, that is a neutral ligand because we don't have any charge over there, that belongs to monodentate since we have one lone pair of electrons. So amine, the ligand name will be amine. So we got to know the ligand name, but we have 6 ligands. So see here, cobalt is surrounded by 6 NH3, 6 ligands. Okay, so in that case we need to add the prefix, the ligand name what we write, and before to that we write the prefix, and that prefix represents how many ligands we have. And prefixes like di, tri, you need to write. So 6 amine we have, therefore hexaamine you need to write. So I am going to write here the name. All are small alphabets only. So what is this actually? This is hexaamine. And try to know, while writing the name of amine, a double M it comes. So hexaamine. Now we write this metal name hexaamine. The metal name is cobalt, so I write here cobalt. So continuously hexaamine, cobalt. Next we are supposed to write the oxidation number of central metal atom, and oxidation number has to be written in brackets, braces, parenthesis in Roman number only. So how actually we write Roman number? If it is oxidation number 1, so we need to write like this. If it is 2, we need to write like this. So oxidation has to be written in Roman numbers in the brackets here. First we need to know what is the oxidation number of cobalt in this coordination complex. So 2 different methods I will tell you, and which one you feel easy, you are supposed to continue with that one. So the first method is as we know in case of first PUC, how to find out the oxidation number of an element present in a compound. In a neutral species, sum of oxidation number is equals to 0, isn't it? In case of ion, the sum of oxidation number is equals to charge present on ion. And if you consider the complex as a whole, so what we have here, so cobalt we are interested in calculating oxidation number of cobalt, therefore I write X. Now we have one ligand, what is that? NH3, single kind of ligand, NH3. As we know, NH3 is a neutral ligand, so therefore what I write? I will write 0 since it is a neutral ligand, but 6 we have, so 6 into 0 you are supposed to consider. And next we have what actually? Cl3 plus. Cl, the charge will be -1, and how many Cl we have? We have a 3 Cl, which is equals to 0. As a molecule whole, it is a neutral. Of course, +3 will be the cation and -3 will be the anion. As a complex, it is a neutral. So how you are supposed to write? So we get X minus 3 is equals to 0 and X is equals to +3. So the oxidation number of cobalt is 3 plus. So what I write here? So oxidation number I write in a bracket, that too in a Roman number, so 3. So oxidation number is over. And next we write what actually? Anion name. So this is complete coordination sphere. We have not left any gap between this. So hexamine continuously we have written and cobalt also continuously. Anion name, we should leave a space to identify which is the coordination sphere, which is the counter ion. Anion, which is the anion? Cl is the anion. Anion, you should write the name of anion as it is. As it is. So what is that? Chloride. Therefore I write here what is actually the chloride will be the name of the anion. Remember, the prefixes has to be considered for naming of ligands only, but not the counter ions. So anion has to be written as it is. If it is Br3, I would have written bromide, iodide, like that. So no need to add any prefixes for the counter ions. So this is how we write the Iupac nomenclature of coordination compounds, in particular complex ion. The complex, the name of this compound will be hexaamine cobalt 3 chloride. Hexaamine ligand, cobalt central metal atom, Roman number 3 inside the bracket, oxidation state of a metal, and chloride will be the anion. And this is very important to know, identify the oxidation state of a central metal ion. But this method is time consuming, and I hope you are quite good in calculating the oxidation number. One more method I will tell you, so that within fraction of seconds you are going to get the oxidation number of that. So X is equals to 3 plus we got. Now I will tell you one more method to identify the oxidation number of central metal atom. Cl, chloride is -1, 3 we have, therefore 3 minus R, right? And if counter ion is 3 minus, definitely the coordination sphere would be 3 plus, because they are supposed to balance each other. So that together coordination sphere and the anion or ion, that should be the neutral. Therefore, since it is 3 minus, this will be the 3 plus. The charge of the coordination sphere is 3 plus. So ligand we have NH3, isn't it? And NH3 is a neutral molecule, therefore I write 0. And now the charge of cobalt, the charge of NH3 corresponds to total charge, that is 3 plus. So since NH3 is 0, now I can easily say the cobalt should be of +3, because sum of oxidation states of central metal atom and ligand, that should be equals to the charge of cation. Try to understand. Let me repeat that. The charge of the coordination sphere is 3 plus. Sum of oxidation number of ligand as well as central metal atom. If you take, you are supposed to add this, we are going to get the charge of the complex. Since NH3 is 0, therefore cobalt should be 3 plus, therefore the charge will be 3 plus. This is how I can say the oxidation number of central metal atom is 3 plus. Right? Next example we'll see. Here, CO we have cobalt, NH3 ligand, 5NH3 we have, Cl we have, that is also ligand, and Cl2 we have, that is anion. So the term inside the bracket is coordination sphere. Inside that we have central metal atom and ligand, and outside we have ion. Remember, here also I have Cl, here also I have Cl. Both the Cl are completely different. This Cl will be the anion and this Cl will be the ligand actually. This is a counter ion. This will be ligand actually, because that is enclosed in the bracket. So now we'll write the name of that. So first what we have to do, we have to identify the ligands and we have to identify the central metal atom. Cobalt is the central metal atom, that is okay. Ligand, we have NH3 and we have Cl. In the previous example, we had only one ligand. Homoleptic complex it was. Now it is a heteroleptic complex, more than one ligands we have. So what are the ligands? We have NH3 and Cl. And NH3, see here, NH3, the name will be amine, isn't it? And Cl, and the name will be chlorido. Amine and chlorido. Amine is neutral molecule, whereas chlorido Cl minus anion it is. Both are monodentate ligands only. So if you have more than one ligands, and the question arises, which one has to be written first? In this case, you have to write the name of ligands according to alphabetical order. So we have two ligands, amine and chlorido, and the first alphabet, first letter you just see. So here we have A and here we have C. According to alphabetical order, amine come first, later chlorido. Let us assume we have such examples, both first letters are AA only. In that case, you need to go with the second alphabet, that we know. So here alphabetical order you need to consider. Therefore, I write amine first, later I write chlorido. So now see, I need to write amine. So amine I need to write, but we don't have only one amine. We have 5. Therefore, prefix has to be added. So what is that prefix for the 5? Penta. Therefore, the name will be pentaamine. Right, so one ligand is over. One more ligand is Cl. What is that? Chlorido. We have only one, isn't it? So chlorido. Next, central metal atom, cobalt. And now the question arises, what is the oxidation number? That has to be written in the bracket. You can calculate, as it is what I explained, how to calculate the oxidation number, and we'll follow this one because this is not time consuming. Cl2. Cl, the charge is 1 minus, 2 we have, the charge will be 2 minus. If the counter ion charge is 2 minus, then definitely coordination sphere charge will be 2 plus. Okay, and now we'll identify this cobalt. So NH3 is a neutral ligand, 0, NH3. So try to know NH3. Okay, H2O and pyridine, methylamine, carbonyl, nitrosyl, these are all the neutral ligands. If you observe the list what I have given, you will get to know, because we don't have any charge over there. Chlorido, Cl minus, that is anion, and this is a neutral ligand, NH30. So Cl we have, what is the charge of the Cl? Cl will be 1 minus, and we are supposed to calculate oxidation number of cobalt. See here, if you consider this as X, and if you consider sum of these 3, that should be equals to 2 plus. So now you need to imagine that. So what will be the oxidation number of cobalt? So that by adding the oxidation number, you should get the total which is equals to 2 plus. So for your reference, I will write here in one more manner here. So X, let us assume this is X, and here we have a 0, and here we have minus 1. I consider only sphere, which should be equals to 2 plus. So if you do this one, we are going to get 2 plus 1, X is equals to 3, or directly you can say this should be 3 plus. Okay, so 3 minus 1 you will be getting a 2, isn't it? So the oxidation state of cobalt is 3 plus. So therefore I write here Roman number 3 inside the square bracket after the name of the metal. So there is no gap in between. Now I need to leave a gap, and I need to write the name of the counter ion, Cl2 minus. What is the anion? Anion you need to write. No need to write the prefixes and all these things. This is the anion. Remember, the name of anion is different, the name of ligands are different. The name of cation is different, the name of ligand is different. Ligand is a complete separate concept. Don't get confused with the anions, cations with the ligands here. So here Cl2 will be the anion, and therefore what I write here, I will write to chloride. While I leave a space, and I am going to write what actually the chloride here. That is the Iupac nomenclature of the second example what I have considered. So try to know pentaamine, chlorido, cobalt 3 chloride. Next example, cobalt we have, NH3 we have, and H2O and Cl3 we have. Coordination sphere we have, and we'll see whether it is cationic complex or not. Cl 1 minus 3 we have, therefore 3 minus it is, and ultimately the charge of the complex will be 3 plus cationic complex. If you observe the terms involved in coordination pair, cobalt is the central metal atom. Whereas we have two different ligands. One is NH3 and H2O is also ligand. So what is the name? NH3, as we know, what is the name of that? NH3 amine. Okay. So do you remember what is the name of the ligand H2O? Aqua. Isn't it? So we have two ligands. As I said, if you have two ligands, you need to follow alphabetical order. So now alphabetical order I consider both are AA only. As I said, if the first alphabet is same, then move with the next one. So next alphabet we have M here, we have Q here, and I hope you can guess. First I need to write the ligand that is amine. Isn't it? So now I am supposed to write the amine. But how many amine we have? 4. We have to add the prefix. Therefore, tetraamine, right? Tetraamine. Next I consider the ligand H2O. Aqua it is, but how many aqua we have? 2. The prefix I write here. What is that? Diaqua, right? Diaqua. Then the central metal atom. What actually this is? This is cobalt, and now I need to write the oxidation number in a bracket. So oxidation number will calculate. The charge of the complex is a 3 plus. NH3 is a neutral ligand, this is 0. Do you remember what kind of ligand H2 is? H2 is monodentate, then it is also a neutral ligand, 0. Since both are neutral ligands only, the charge carried by the complex is same as the charge carried by cobalt. Oxidation state of cobalt here is that is 3. Therefore, I write in a square bracket here. And the anion we have a Cl3, that is nothing but the chloride anion we have. So, I write here a chloride. So, that is the name of this particular compound. Remember, since I have two different ligands, amine and aqua, I followed the alphabetical order. First alphabet is same, therefore second I consider. But remember, you need to follow alphabetical order of the ligands, but not prefixes. See here, I followed amine, but not tetra and di. Try to know alphabetical order of ligands we write, but not the prefixes of ligands. Don't confuse with that. So that is how Iupac's nomenclature of the third example, tetraamine, diaqua, cobalt 3, chloride. Example number 4. Cobalt we have central metal atom. Ligand we have NH3. One more ligand we have a CO3, and we have anion Cl minus. Two ligands we have. What are these two ligands? One is amine. Okay. And we have a CO3. Do you know that one? What is that? That ligand name is carbonato. Do you remember carbonato? CO3 2 minus is carbonato. CO3 2 minus, carbonato it is. So, we have amine and we have a carbonato, and the central metal atom is cobalt. So, now we need to follow the alphabetical order. So, A we have and C we have. Alphabetical order, amine has to be considered first. Amine, but how many amine we have? 5 amine we have. Prefix has to be added. So, what is that prefix? Penta-amine, right? And one more ligand we have CO3, and we have only one CO3, carbonato. And next we have central metal atom, carbonato, and that is cobalt. We have a cobalt, and after the name we need to write what actually the oxidation state in Roman number. Cl it is 1 minus, this should be 1 plus. Okay, the total charge will be 1 plus. NH3 is a neutral ligand, isn't it? CO3 the charge will be 2 minus, as I mentioned, carbonato 2 minus it is. And what would be the oxidation state of cobalt? So that if you add these two, the total charge should be 1 plus. I think this will be 3 plus, because 3 minus 2, you will be getting 1. Cobalt oxidation state is 3. So, that I write in a Roman inside the bracket. Anion is Cl, so that I leave a space and I write what actually chloride anion. So, the Iupac name will be pentaamine carbonato cobalt 3 chloride. Remember CO3 we have. actually in the ligands we are not going to mention the charges because ligands are not alone, they are supposed to attached with the central metal atom. So during coordination compounds, so after the formation of coordination compounds, we don't represent any charge. So here we write Cl, we don't write Cl minus because that has been involved while formation of coordination compounds. Example number 5 we'll see. It is bit interesting. If you observe the example what I have written, CO cobalt, we have En. 3 En we have and Cl3. Do you know what is that En? As I said, En is nothing but 1 ethane 1,2-diamine. Let me write that. What is that En? Ethane 1,2-diamine. Ethane 1,2-diamine. And the structure I am going to write NH3 CH2 CH2 and NH2. So ethane 1,2-diamine. Do you remember what kind of ligand it is? Whether it is monodentate, bidentate, polydentate, ambidentate. So ethane 1,2-diamine belongs to bidentate ligand. Why? Because on nitrogen we have lone pair of electrons and on nitrogen we have lone pair of electrons. So two lone pair of electrons are going to donated, therefore this ethane 1,2-diamine belongs to bidentate ligand, and this ethane 1,2-diamine we write in the form, the symbol will be En. And remember, we don't have any charge over here, we don't have any charge on this ethane 1,2-diamine, therefore ethane 1,2-diamine is a neutral ligand. The charge that is known to you, whether it is positive, whether it is neutral, whether it is neutral. So we don't have any charge over here, therefore ethane 1,2-diamine is a neutral ligand here. So we need this En, it will be the ethane 1,2-diamine, and cobalt we have, and we have a Cl. So now we have to write the ligand name first. Ligand ethane 1,2-diamine. So let me write that ethane 1,2-diamine. Ethane 1,2-diamine, ligand name. But we don't have only one En, we have a 3 En, so we have to add the prefix. So what the main concept will come in our mind, if we have 3 En and we need to write the prefix as tri, since we have a 3, but I should not write the prefix as a tri, and here I am going to use a new kind of a prefix, and a new kind of prefix I am going to write here. So what is that new kind of prefix I am going to write here? So now if instead of di, tri, tetra, so we can consider one more kind of prefix, that is bis we are supposed to use if the ligands are 2, and tris we are supposed to use if we have 3 ligands, and tetrakis has to be used if we have 4 ligands. So this is the new kind of a prefixes has to be considered. 2 ligands we have bis, 3 ligands if we have tris, and 4 ligands we have, then you are supposed to use tetrakis as the prefix. And the question arises, why we can't use di, tri, tetra in this case? So the rule I will tell you. This is the ligand name, isn't it? So just observe the ligand name. In the ligand name itself we have a prefix. Where it is? Just see, in the ligand name itself we have a prefix diamine. Di is also prefix. So if in the ligand name itself we have a prefix, then we are supposed to not use the regular prefixes. This kind of prefixes has to be used. Now if you see the previous examples, amine we have, chlorido, amine, aqua, amine, carbonato. So in all these cases we don't have any prefixes, therefore we just use the normal prefixes like di, tri, tetra. Whereas in this particular ethane 1,2-diamine we already have a prefix, therefore the new level of prefix has to be considered, that is bis, tris, tetrakis here. Since En3 we have, so 3 ligands, I need to write what actually tris here. So this has to be written in a bracket tris and ethane 1,2-diamine. I think now you came to know why I used tris instead of tri, because in the ligand name I have already prefixed di. Next, ligand is over. Next, cobalt. Okay, so cobalt iron, continuous cobalt iron. And next I need to write the oxidation state in a bracket. So Cl3, the charge of counter ion will be 3 minus. The charge of the coordination sphere is 3 plus En. What would be the charge of En? As I said, En is a neutral molecule. Therefore, I write 0. If it is a neutral molecule, the charge 3 plus, the cobalt will be of 3 plus only. Therefore, I write the Roman number 3 in a square bracket. That would be the oxidation number of cobalt. And anion is a Cl, that is a chloride. So, space I leave and I am going to write what actually the chloride. So, this is how you are supposed to write the nomenclature of a coordination complex in this manner. 5 examples are discussed. Let me repeat what I explained in a very short manner. First, identify whether the coordination complex is cationic, anionic or neutral by knowing anion will be 3 minus, this is a 3 plus, therefore the charge will be positive, positively charged complex. In general, this is the rule has to be followed. Ligand name, later metal name, later oxidation state of a central metal atom, that to be in a Roman number inside this bracket, and later we need to write anion. Coordination sphere has to be written continuously. So from here to here, coordination sphere write continuously, then leave a gap and write the counter ions. And all the alphabets are small alphabets only. And if you have more than one ligands, and that ligand name has to be written in alphabetical order. And if we have the more than same kind of ligands, then prefixes used like bi, tri, tetra, penta, hexa, hepta, octa, you need to use that. In the ligand name, if you have the prefixes, in that case you have to use such kind of prefixes as bis, tris, tetrakis, like that. And remember, the names of the ligands are very important to understand, and you need to remember the table what I have given in the previous session. Remember the symbols and remember the charges also, and remember the names also. And now oxidation state of central metal atom is a very important one, and you can follow this method as how we used to do oxidation number as it is. And now I represented one more method, I explained one more method to identify the oxidation number. You can use any one if you want, but try to identify the correct oxidation number so that the correct name we are going to get. That is all about the nomenclature of cation complexes. Now I speak about Iupac nomenclature of anionic complexes. Complexes with negative charge is considered as anionic complexes, and the rule is completely different as compared to cationic complexes. So now first identify whether the given coordinate compound is anionic complex or not, and then it is going to be followed, and then follow the rule what I have written in short manner. First we need to write cation name. Cation name as it is. In case of cations, how we used to name that, so as it is we are supposed to write the cation name. And next we need to write a ligand name. Again the same rules has to be considered. If you have more than two ligands, two different ligands according to alphabetical order, and if you have a same ligand of the more than one, then prefixes you are supposed to add. The same rule has to be followed. Next we need to write a metal Latin name, and AT I have written, I will tell you what is that, and later we are supposed to write what is that oxidation number of central metal atom. And if you consider the first example what I have written, and remember this part K4 what I have written, that is the counter ion, and the term in the square bracket, that is a coordination sphere, whereas in case of a cationic it was exactly the opposite. First we have a coordination sphere and then we have a counter ion, whereas in case of anionic species first we have a cation and later we have a coordination sphere. And first we'll see whether it is cationic complex or anionic complex. So potassium we have, and the potassium charge will be 1 plus, so therefore 4 we have, therefore this should be 4 plus. If the charge of the counter ion is 4 plus, definitely the charge of a coordinate sphere should be 4 minus, because as I said, counter ion is going to balance the charge of the coordination sphere. That is the main function of the counter ion. So now we have to write the cation name, and cation name is over. Leave space, and after write the name continuously ligand name, metal Latin name and oxidation state. So there is a gap between cation name and the coordination sphere what we write. And as I said, coordination sphere, the name you need to write continuous. All the alphabets are small alphabets only. Ligand name, of course we know, based on the symbol what we have, we are supposed to write the ligand name. And now here comes the very important one, a metal Latin name. In the previous case, I just mentioned a metal name, but here in anionic complexes, I represented metal Latin name. So Latin name only you are supposed to write that. So what is that actually Latin name? So let me explain some very simple concept how we are supposed to write the metal Latin name. Usually the elements are represented by symbols. We know this one, isn't it? Sometimes the first letter of the name is considered as symbol. Example, hydrogen, if you consider, the first alphabet is H, therefore capital H will be the symbol for hydrogen. In some cases, the first two alphabets are considered as the symbol for name of particular elements. One example, calcium. Calcium, we write capital C small a, Ca, the first two alphabets we considered. We have such kind of examples where we use the Latin words for naming actually. One example I consider. So example I am going to consider here is iron. So Fe, iron. Okay. But while writing the name of that, we use the terms like ferrous and ferrite. Iron is the English word and ferrous and ferrite, they are Latin words. So if iron is 2 plus ferrous, if iron is 3 plus ferric, we use ferrous and ferrics. As we know, iron has two valencies. These we call it as variable valencies. Any species, if it has more than one valency, we call it as variable valency. And the lower valency and higher valency you can consider. So the lower valency we have, and the word should end with us, O-U-S. For the higher valency, the word should end with ic, I-C. Therefore, ferrous and ferric. And lead, if you consider, lead. So what is that lead? Lead, Pb we write. Okay. And Pb is the lead. And for lead we have two different valencies. We have 2 plus and we have 4 plus. Lead has two different valencies, 2 plus and 4 plus. Lead is the English word. Plumbus and plumbic will be the Latin word. Plumbus and plumbic. Similarly, cuprous and cupric we have, aurus and auric we have, mercurus and mercuric we have. So all these are the Latin names. So in this case we are supposed to use the metal Latin name. One example I consider. So in the first example itself I have iron, Fe, and here you are not supposed to write the iron because that is the English word. You need to write the Latin name based on the oxidation state, whether it is ferrous or ferric. So based on that you are supposed to write. So metal Latin name you are supposed to write. And remember that the metal Latin name what you write, that is going to end with ate, 8. Ferrate, if you have a Fe and you are supposed to end the word with the ferrate, so ate will be suffix we are supposed to add to metal Latin name. Try to remember, in an ionic complex the metal Latin name has to be end with ate. Fe we have ferrate. Okay, and if you consider a Pd, what is that Pd? Palladium, palladiate, and we have a nickel and a nickelate. Okay, zinc, zincate, cobalt, cobaltate, whatever the name we have, and that has to be end with the ATA. And later we are supposed to write the oxidation state of central metal atom, that too in a braces, that too in a Roman number. So this is the rule what I am supposed to tell in a brief. So now we'll see examples. So examples are the very important one. The rule I said to understand the fundamental so that we can write the names. Of course the rule is not required. I think if you solve the examples you will be knowing the rule itself. So the first example I considered, well known example of a coordination compounds, K4FeCN6. Now we'll write the name of this compound, and first you need to identify whether it is cationic and anionic. Cationic, the method is different. Anionic, the method is different. Since it is a potassium, 1 plus, 4 we have 4 plus, the charge of the complex will be 4 minus. Since the complex contains negatively charged, therefore this is a negative charged complex here. And in negatively charged complex, first we have to write the cation name. Which one is the cation? K is the cation, K plus, potassium. All are small alphabets here, so therefore I write potassium. Yes, this is the counter ion. I am supposed to leave the space. Next you consider FeCN6. In FeCN6, next we are supposed to write the name of the ligand. Name of the ligand. We have only one kind of ligand. What is that ligand? Cn minus. See here, the ligand here what we have is Cn minus, and now the name will be, as I have given, the name will be cyanido. The name will be cyanido. The name of this ligand Cn minus is cyanido monodentate ligand, negatively charged monodentate ligand I can say. And next we have cyanido, only one ligand. Okay, so next ligand name I am going to write potassium. Cyanido I am supposed to write, but we have 6 ligands, therefore prefix we add, so therefore hexacyanido, right? Hexacyanido. Ligand name is over. Now metal Latin name iron, don't write ironate, that is the English word. And Latin ferrate, so ferrate, the word should end with ate, ferrate. Okay, and now we have to write the oxidation number in a square bracket. So now how to find out the oxidation number? So the +4 we have and -4 we have, and Cn, and we are supposed to calculate the oxidation number of Fe here. So Cn, the charge will be 1 minus, but we have a 6 Cn, the charge will be 6 minus. So what would be the oxidation state of Fe? So that if you add the oxidation state of Fe and oxidation state of this particular 6 minus, and you will be getting 4 minus. So what would be that? I think this will be 2 plus, isn't it? Because 2 minus 6 will get a -4, isn't it? So therefore oxidation number of iron will be +2, and that I write in Roman number, that too in bracket here. So therefore the name of this compound will be potassium hexacyanidoferrate. One more concept I want to highlight here. In the year 2004, IUPAC board, International Union of Pure and Applied Chemistry, in short we call it as IUPAC. The names of the compounds is given by the board IUPAC nomenclature. In the 2004 they changed certain rules of naming of coordination compounds. In earlier days, before 2004, this Cn minus we used to write it as cyano. Cl minus chlorido we write. Earlier we used to write chloro, bromo, fluoro. So we used to write just as a cyano, but after 2004 the rules has been changed, therefore O is going to be replaced by IDO, therefore cyanido, chlorido, bromido, iodido, fluorido, we get IDO in this fashion here. So because if you refer some other books for competitive examination, you may get the name as a potassium hexacyanoferrate too, that is also right, but recent nomenclature we have to write cyanido only. Therefore I prefer, as per NCERT, as per latest IUPAC nomenclature, you need to write cyanido only. If you write cyano, that was the old nomenclature, that is also right. Know that concept. Now I come to the next example. So we have a K3FeCN6. It is almost the same as out of the previous one. Only the thing is, in the previous one we have K4 and here we have K3. And how to name these compounds? First, let me identify whether it is anionic complex or not. So potassium 1 plus 3 we have, therefore 3 plus will be the charge. If the counter ion is 3 plus, ultimately the coordination pair would be 3 minus. So we'll try to identify the oxidation number, and finally we'll write the name here. So Cn we have, the charge will be 1 minus, totally 6 minus. So what would be the oxidation number of iron? So that after adding with the -6, you should get the answer as 3 minus and 3 plus, isn't it? So 3 minus 6, you will get 3 minus. Oxidation number of iron in this compound is 3. So we'll write the name. First we need to write the cation. So what is the cation? Potassium. Leave space. FeCN6. First we have to write the ligand cyanido. How many we have? 6 we have. Therefore potassium hexacyanido. Next, central metal atom iron, Latin name and should ATE, therefore ferrate. Oxidation number of iron, that is 3, therefore 3 in a Roman bracket I write. That would be the IUPAC name of this. Next example, K3FeC2O4 thrice we have. We'll see anionic complex or not. K3 we have, the charge will be 3 plus and the charge of this pair will be 3 minus. We'll find out the oxidation number of this iron. So C2O4 3 minus we have. Do you remember that? What is that actually? C2O4. So C2O4 2 minus, this name will be oxalato, but we write as OX, oxalato. And you need to know oxalato, this is a COO minus and we have a bond COO minus. So this oxalato is going to donate 2 lone pair of electrons. Therefore oxalato belongs to bidentate ligand. So bidentate ligand C2O4, we don't mention the charge, so C2O4 3 minus. So this will be the ligand, iron will be the central metal atom, and K3 potassium will be the counter ion. We'll write the name K3, that is nothing but the potassium. Right. Next, we are supposed to write the ligand name. What is that? Oxalato. Oxalato. How many we have? 3 we have. Therefore, the prefix. What is that prefix? Tri. Oxalato. Isn't it? Trioxalato. Next, we have central metal atom iron. And you need to write the Latin name. Ferrous. And ATE. Ferrate. Okay. And we are supposed to write the oxidation number of the iron, and that has to be written in a bracket, and we need to calculate the oxidation number. Since the charge of the complex is 3 minus and oxalato will be 2 minus, totally 3 minus, isn't it? One oxalato, the charge will be 2 minus, totally we have 3, therefore 2 into 3, 6 minus we have. And what would be the charge of the iron, so that we get the answer as 3 minus? I think this will be 3 plus, because 3 minus 6 will get a minus 3. Oxalato, trioxalato, ferrate, 3 will be the oxidation number, and that is the name of that. So this is a counter ion and this is a coordination pair. Continuously all alphabets are small alphabets only. Next example, K2PdCl4. Potassium will be the counter ion, Pd, palladium will be the central metal atom, and Cl, chlorido, will be the ligands. First we write the name of the counter ion. K2 we have, the charge will be 2 plus and the charge of this will be 2 minus. So potassium, right? Next we have a Cl, ligand will be Cl, and how we write that one? Chlorido. But how many we have? 4 we have, therefore tetrachlorido. Tetrachlorido. Pd, palladiate. The word should end with ATE, palladiate. And in bracket we are supposed to write the oxidation number. The charge of the complex is 2 minus, Cl will be 1 minus, totally 4 minus. And what would be the charge of Pd? What would be the oxidation state of Pd? So that if we add these, you will get 2 minus. This will be 2 plus, because 2 minus 4 will get 2 minus itself here. Therefore, the oxidation state will be what actually, that is the 2 that I write in Roman number, right? So potassium tetrachlorido palladiate 2. Now I consider example 5. Just observe that example 5. We have NiCl4 square bracket 2 minus. Now you can easily say coordination pair has a negative charge, therefore anionic complex it is. But the only thing is, in the previous examples we have a counter ions, cations, but we don't have any counter ion cation. In that case, if we don't have counter ion, if we don't have anion, leave that. That's it. So directly I don't mention cation name. I will move with the next one, ligand name. Which one is the ligand? Cl4, chlorido. 4 Cl we have. Therefore the name will be tetrachlorido. Tetrachlorido. Ni, nickel is a central metal atom, and nickelate, word should end with ATE, nickelate, and in the bracket I need to write the Roman number. Yeah, I need to write the oxidation number. Tetrachlorido nickelate oxidation number. The charge will be 2 minus, Cl will be 1 minus, therefore 4 minus I write, and the charge will be 2 plus nickelate 2. So nickelate 2 I write. So therefore tetrachlorido nickelate 2. But these are neutral molecules, but this is anion. because we don't have a cation, we have a charge over here. So observe here, we don't have any charge, but here we have charge. Therefore the word should end with the word ion. Remember, in the last example, we don't have any counter ion, we don't have cation, that is a particular perfect anion. Therefore the word should end with anion. In the previous cases, just to observe, anyhow I have written the charge. Originally these are the coordination compounds, they don't have any complexes because the charge of anion is going to be balanced by the cation. The charge of the coordination sphere is going to be balanced by the counter ion, whereas in this case we don't have any counter ion to balance the charge of the complex. Therefore the word I introduced, what is that ion? Therefore tetrachlorido-nicolate 2 ion will be the name of this particular compound. This is all about the Iupac nomenclature of anion with the complex here. Remember, first unit write cation name, next ligand name, and the respective rules has to be followed. Then a metallality name, the word should end with ATE, and we are supposed to write the oxidation state of that one, and the same method you are supposed to write how to find out the oxidation state of that. Remember that the metal name word should end with ATE, ferrate, palladiate, nicolate. If you have zinc, zincate, cobaltate, like that, the word metal name, that to be in a Latin name, the word should end with the ATE. That is all about the Iupac nomenclature of anionic complexes. After cationic complex and anionic complex nomenclature, we'll see how to name neutral complexes. As the name indicates, we have a complex, but it is not carried with positive or negative charge. Complex species without any charge, that is considered to be neutral complex. And all these are the neutral examples. Now if you observe here, we have a coordination sphere, isn't it? And we don't have any counter ion. And in the coordination sphere, even though we have, and we don't have any charge over there, therefore these belongs to neutral complexes, and the rule has to be followed. First you need to write ligand name with suitable prefix and following the rules of ligands, and next metal name as it is metal name, and we need to write oxidation state in square bracket, that in Roman number. The rule is very simple. Now we'll see the examples. The first example I have NiCO4. So Ni, nickel will be the central metal atom, and CO we have capital C, capital O, carbon monoxide it is, not cobalt, carbon monoxide. And do you remember the CO what we write? The CO, this that is a ligand in a particular, that is a monodentate ligand, and I can say neutral ligand, and the name will be carbonyl. In the list I have mentioned this monodentate ligand, in particular neutral ligand it is, the name is carbonyl, capital C, capital O, carbon monoxide, carbonyl we call it as according to the rule. So therefore carbonyl will be the ligand and Ni will be the central metal atom, and we'll write the name of that. So ligand name has to be written first carbonyl, but how many carbonyl? We have 4 carbonyl, prefix tetra you are supposed to add here. So therefore the name of this compound will be tetracarbonyl. Right. So next metal name nickel. Metal name nickel. Don't write nicolate, because nicolate we write in case of anionic complex only. For cationic complex we write the name as it is. In case of neutral ligand, neutral complex also we write the name as it is. So therefore tetracarbonyl nickel, and in the bracket we are supposed to mention the oxidation number. So as a whole it is a neutral molecule, the charge will be the 0, and sum of oxidation states will be equals to 0. Carbonyl is a neutral ligand, therefore the charge will be 0. If the carbonyl is only one ligand, we have one kind of ligand, the charge is 0, then ultimately the charge of nickel will be also 0. The name of this coordination compound will be tetracarbonyl nickel 0. Tetracarbonyl nickel 0 it is. Next one we'll see, it is also of the same kind. FeCO 5 times we have. Iron will be the central metal atom, CO, carbonyl will be the ligands. We have 5 ligands, therefore the prefix I am supposed to consider here is pentacarbonyl. All this is the coordination sphere, continuously we are supposed to write pentacarbonyl. Iron we have, see here, iron, we don't write ferrate because this is a neutral molecule, neutral complex. So iron, the oxidation state, so carbonyl is a neutral, then ultimately iron should be also 0. So therefore the oxidation state of iron in FeCO 5 times, that will be 0. Therefore the Iupac name will be pentacarbonyl iron 0. Now I will come to example number 3. PT we have and Cl we have and NH3 we have. So PT, platinum, will be the central metal atom. One can easily guess. And if you consider all the examples what I discussed, all these are D block element, transition elements only. So platinum is a transition element and Cl and NH3, two different ligands we have. Heteroleptic complex it is. Therefore the first one is, what is that? The ligand Cl minus, and we call it as chlorido, isn't it? And one more thing, one more ligand is NH3 and we write it as amine. So Cl minus, the charge will be 1 minus. NH3 is a neutral molecule, 0 it is. And now if we have more than one ligands and we are supposed to write the ligand name according to alphabetical order. So in between C and A comes first, therefore amine I am supposed to write. So amine I write, but I have 2 amine, therefore I am supposed to write diamine. Diamine. Next chlorido, how many we have? 2 we have, therefore diamine, dichlorido, right? Diamine, dichlorido. Next we have PT, so platinum, platinum. If it is ionic platinate, I would have written platinum. In a bracket, we will write the oxidation number. So as a whole, it is a neutral. Among NH3, amine will be the neutral, and Cl it is 1 minus, totally it is 2 minus. So if it is 2 minus, this should be 2 plus, because as a whole it is a neutral. So 2 plus 2 minus equals to 0, we are going to get platinum will be 2. Therefore that 2 I write in a Roman number, that to be in a bracket. Therefore diamine, dichlorido, platinum 2 will be the IUPAC name of this compound. Next compound, you see, it is quite big, and don't afraid of the very lengthy the formula what we have, just follow the rules. Entire it is a coordination sphere, and we don't have any counter ions, that is a neutral complex. And in these we have PT, we have BrCl, C5H5n, and NH3 we have. And among these, which one is the central metal atom? D block elements, transition elements. Platinum is the central metal atom. So platinum will be the central metal atom, and remaining these are ligands. So the first what we have Br, and what we write Br, it is actually Br minus. How we write the name? Bromido. For your reference, I am writing here a kind of rough work. Otherwise, we can directly write the name without performing any rough work. So Cl we have. So Cl minus. So what will be the name? Chlorido, right? And we have C5H5n. So do you know what is that? C5H5n. Actually, this we write in this fashion. And this in short we write PY, pyridinities. Okay, and the symbol will be PY, and this is pyridine. And this is also neutral molecule because we don't have any charge over there. Next we have NH3. What is that? NH3. NH3 will be amine. AMMINE. Try to know. In IUPAC nomenclature of these, we write AMMINE. So we have 1, 2, 3, 4. 4 ligands we have. And these 4 ligands we have, and we need to write in alphabetical order. So which one first comes? Br, Cl minus, and this we have pyridine and NH3. So B, C, P, A we have. A comes first. Okay, so amine will be the first ligand. So what I am going to write now here is, now amine I am going to write. So how many amine? Where it is? Sorry, here it is. So how many amine we have? Only one. Therefore amine. Next, after amine we get B, bromido. So how many bromido we have? Only one. Therefore I write as it is bromido, amine, bromido. Next, after A, after B, we will get C, that will be chlorido. We have only one chlorido, amine, bromido, chlorido. Next, one more ligand we have. What is the last one? Pyridine. So that I write pyridine. Okay, so ligand name, quite lengthy ligand name we got. Next, we write the metal. What is that metal? Platinum. Platinum. And we need to write the oxidation state of that. Amine will be neutral, pyridine is neutral, Cl will be 1 minus, Br will be 1 minus, totally 2 minus we have, therefore this should be 2 plus because together it should be 0. So platinum 2 will be the name. So just follow the rules, you will be getting the right name. And all this is a coordination pair, so continuously with all small alphabets are right here. So try to know amine, bromido, chlorido, pyridine, platinum 2, that is a neutral complex we have. One more example I consider, PT NH32Cl NO2. Now I hope you can identify the platinum will be the central metal atom. We have 3 different ligands. One is NH3 amine, one is Cl minus chlorido, okay, one is amine and one is chlorido. One more we have, what is that? NO2 we have. So let me talk about that NO2. First time I am using this NO2 ligand. As I listed in the column of the different types of ligands, with respect to that, let me write what I have given actually. So NO2 1 minus and the name will be nitro, okay, and NO3 1 minus nitrato, and ONO 1 minus, this is nitrito. Don't get confused with the, therefore I am going to write all that. So nitro, nitrato, nitrito, we have a NO2. So NO2, so this is also possible and this is also possible because NO2 1 minus we have and as it is NO2 1 minus we have, but these two are not exactly the same. What is the different I am going to explain here. So try to understand this NO2 1 minus R, right? This is an example of ambidentate ligand. Ambidentate ligand. I hope you know what actually the ambidentate ligand stands for. That is a kind of ligand in which we have 2 ligating atoms, more than 1 ligating atoms, but when complex is formed, only 1 ligating atom is going to attach with the central metal atom. So in this nitrogen, in between nitrogen and oxygen, nitrogen is also ligating atom, oxygen is also ligating atom. Since nitrogen oxygen both contains lone pair of electrons for the donation, therefore NO2 minus will be one of the best example for ambidentate ligand. Some other examples I said Cn minus, Nc minus, like that. Okay, so now let me draw the structure of that so that it will be more clear how I am going to consider that. So N O and O, NO2. If nitrogen will be the ligating atom, this is how I am going to say nitrogen is going to link with the metal. Nitrogen will be the ligating atom. In some other cases, so let me write here. So N O double bond O. In some cases, oxygen will be the ligating atom. Oxygen is going to link with the metal. So in NO2, nitrogen may be ligating atom and oxygen may be ligating atom. So out of these two, one metal is going to ligate. Therefore, that belongs to ambidentate ligand. And in general, we write nitrato and nitrito. In particular, this particular compound, the name I am going to write here, and this I write it as here I am going to write. This will be nitrito hyphen N I write, and this one I write nitrito hyphen O I write. So what is the difference between the two? What is the meaning of these two? Both are nitrito only, but in this case nitrogen will be the ligating atom or nitrogen is going to attach with the metal, therefore N I write, and here oxygen is going to attach with the metal, O I write. So if I write nitrite to N will be the ligating atom, N is going to join with the metal. If I write nitrite to O, and O will be the ligating atom. So instead of using nitrate to nitro, in particular more correct we use nitrite to N, nitrite to O. So this is a kind of arrangement you need to know whether it is N is the ligating atom or O is the ligating atom. So if you know this, I can move with the name of this one. So NH3Cl NO2, this is amine, this is chlorido, this will be nitrito. So first comes amine. So therefore let me write the name, and since we have a 2, therefore diamine. Diamine I write, and next will be Cl, that is nothing but chlorido. And we have NO2, and that I write it as nitrito. N I have written first. I have not written in this fashion. I have not written ONO. So N I have written means N is going to ligate with the platinum. N is going to attach with the platinum. We have NO2. If it is ONO, I would have written nitrite O. But here N we have first. This will be more prefers nitrite N. I write here nitrite N because N will be the ligating atom. So this is actually N is going to ligate with that one. Instead of writing only nitrato, you can write a nitrato also. Okay, nitrato, that will be the older IUPAC nomenclature. In correct manner, nitrito N, nitrito O we write, which is going to be ligating atom. So N we have. So nitrito N. Next we have to write the name. So platinum. And in a bracket we are supposed to write the oxidation number. So what will be the oxidation number of platinum? So NO2 will be 1 minus, chlorine will be, chloride will be 1 minus, and ammonia will be the neutral. So 2 minus we have totally, this should be 2 plus, therefore in a bracket I am going to write what actually 2. So this is how you are supposed to write the IUPAC nomenclature of neutral complexes. First we write the ligand. Later we write the metal name and we write the oxidation state. So it is very important to identify whether the given coordination compound is cationic or anionic and neutral. And first you have to find out that, and later apply the rules what I explained. And in ambidentate ligand, especially in this case, you should be careful which will be the ligating atoms. Here if in the molecule we have ONO, I would have written nitrito O. Here N we have, N I have mentioned means N is going to ligate, therefore nitrito N platinum I have written. Remember, in case of anionic complex, the metal name has to be written in Latin with the word should end with ate, platinate, nickelate, zincate, ferrate, like that. And ligands, write the name as it is. So it is compulsory. This is the reason the previous session is a very important one. Session number 1 of coordination compounds. All the fundamental terms I explained. And if you don't know the fundamental terms and you are not going to anything about the writing the nomenclature of this, so first be perfect with the fundamental concept of what I explained. What is coordination number? What is ligand? What is central metal atom? What is coordination entity? Counter ions? All these fundamental concept, be perfect in that one. And you should be quite good in calculating the oxidation number, ligands names. So practice the symbols of the ligands, what all I have given, and try to remember the names also. Try to remember which is neutral. So in general I will tell you, if you consider the examples what I told, NH3 is neutral, H2O is neutral, CO is neutral, NO is neutral, pyridine is neutral, okay, and CH3NH2, methylamine, that is also neutral, and some anion we have, some positively charged ions we have, bidentate ligand we have. So oxalato, ethane 1,2-diamine, bidentate ligand. We have one polydentate, in particular hexadentate, EDTA we have. So all these names and the symbols you need to remember, so that we will be quite good in writing the IUPAC nomenclature of coordination compounds. That is all about 5 examples I solved for cationic and anionic and neutral. In the next session, we'll practice IUPAC nomenclature of coordination compound by considering some random examples. We'll practice in general how to write IUPAC name of coordination compounds.